Hey sunshines! So I want to talk a little bit about trigonometry and the relationship between sines and cosines of complementary angles. So first we want to talk about why complementary angles matter. So the two acute angles of a right triangle are complementary because we know that the triangle adds up to 180 degrees. So that means angle O, angle Z, and angle O, angle E, and angle Z add up to 180. So Z plus O plus E equals 180. Well, we know that E is 90. Because that's our right angle. So that leaves angle Z plus angle O equals 90. The definition of complementary is two angles that add up to 90 degrees. So that means that the two acute angles are complementary. This matters because there is actually a relationship between the sines and cosines. So the sine of angle Z, we know that sine is opposite over hypotenuse. So we look at the opposite side. So the opposite of Z is Z. And then the hypotenuse is E. And then cosine is going to be the adjacent. So O is the side that's next to angle Z, so that's the adjacent leg. But it's still over hypotenuse. So everything's going to be over E. Sine and cosine are always both over hypotenuse, so they're both E. So now we do the other angle. So O, well, the opposite of O is the side that was adjacent to Z. So the sine of O is going to end up equaling the cosine of Z. It's going to be the same thing. It's O over E. And the cosine of O is going to be Z over E. Because Z is adjacent to O. It's opposite Z and it's adjacent to O. So the sine for one is going to be the cosine for the other. So these two match and these two match. So that forms a rule. The sine of any angle is always going to be equal to the cosine of its complement. So the sine of any number equals the cosine of its complement. So you just subtract from 90 degrees and you can find the other number in a problem like this. So for example, sine of, let's say, 62 equals the cosine of 90 minus 62, which is 28. Make sense? Have a good day, sunshines.